After calculating t-statistic, we use the p-value to quantify the probability of getting such a result by chance. P-value tells us if the null hypothesis, that is beta is equal to 0, is true, then what is the probability of getting a result like the one we observed, or more extreme is just by chance, or we can say due to sampling variation. It's like knowing how surprising is the result we got if the null hypothesis is true. The cutoff we set to decide what is too unlikely is called significance level, or alpha. If the p-value is less than significance level, the result is too unlikely to have occurred just by chance. So we reject the null hypothesis, that is beta is equal to 0. The significance level also represents our tolerance for uncertainty, meaning how much risk we are willing to take of being wrong, that is the risk of making a type 1 error. To check p-value manually from t-distribution table, we need the calculated t-statistic and degrees of freedom. Then in the row of our degrees of freedom in t-distribution table, we search between which two values our absolute t-value lies. Then the corresponding two-tailed probability of those columns give us the range for the p-value. If the p-value is smaller than alpha, we reject the null hypothesis. Assuming our t-statistic is 2.5 and degrees of freedom is 20, and we take the significance level to be 5%, then when we search in the table, we will find our t-statistic to be between the values of 2.086 and 2.528, having corresponding probability range between 0.02 or 2% to 0.05 or 5%. In this way, we know that the p-value must be lower than our significance level, and we reject the null hypothesis and conclude that the relationship is statistically significant. In real life, the softwares like R, Stata, eViews, and others calculate the p-value directly for us. Follow for upcoming videos.